Okay, this is video number 5, and we are on slide 25, looking at the two important kinds of phagocytes, macrophages first, and then neutrophils. So, macrophages. Macrophages are an important phagocyte that are present in tissues. So they come from monocytes in the blood. The monocytes then squeeze into the tissues and they develop into macrophages. And we can think of the macrophage as being the beat cops of the innate immune system, kind of hanging out on the streets looking for trouble. They have toll-like receptors, which allows them to detect their environment and look out for things like peptidoglycan or flagellin, those microbe-associated molecular patterns. If they do detect a microbe, their toll-like receptors will be triggered, and those toll-like receptors will transmit a message often to the nucleus, maybe turning on the production of cytokines. Then cytokines will be released into the body, and they will have all kinds of different effects. So their job is to phagocytize bacteria, also to phagocytize dead cells and debris, and destroy invaders. They can live weeks or months, as it states there, and they can regenerate their lysosomes. So they can eat a bacteria, they can send in their lysosomes, fuse, destroy the bacteria, and then they can do the whole thing again. They can regenerate their lysosomes, they can eat some bacteria, fuse their phagolysosome, destroy that bacteria, spit out the pieces, and then they can go on to the next bacteria, continually eating not just bacteria but dead cells from the environment. If a regular macrophage isn't tough enough, if those beat cops aren't tough enough to deal with the pathogen, through various processes that relate to the adaptive immune system, we can activate our macrophages. And an activated macrophage is just more powerful. My analogy here is that you've gone from beat cops to a SWAT team. And there's so our macrophage gets activated, becomes more powerful. If the activated macrophage is still not tough enough to deal with the pathogen, activated macrophages can get together. They can fuse into these things called giant cells. And giant cells, just what they sound like. There's a picture of a giant cell, again increasing the killing power of our macrophage. So we've gone from beat cops to SWAT team, and now we are kind of at the National Guard. We've got tanks rolling in with our giant cells. But still, sometimes giant cells can't do the job. In an infection like tuberculosis, it can be very difficult for even giant cells to take care of. So sometimes the best that our body can do is just to call a halt and surround the bacteria, prevent it from spreading any further. In that case, things like macrophages and giant cells and T cells get together and they form these structures called granulomas. They wall off the invading microbes, but at the downside, as they build up, they can destroy tissue function. So one of the outcomes of tuberculosis is the buildup of granulomas in the lungs and destruction of the lung function. So comparing that now, our macrophages on slide 27, to our neutrophils. So neutrophils, think of those as the rapid responders. These are the guys who are called out of the bloodstream so that splinter gets into your skin, penetrates your skin into your tissues. We have all of those responses triggering of the complement system, for example, maybe a macrophage eating some bacteria and releasing some cytokines. One of the things that happens then is the attraction of phagocytes to the site of infection. And the first kinds of phagocytes that are attracted are going to be neutrophils. They arrive in the blood, they stick to the blood vessels are leaky, and the neutrophils can squeeze out of the blood and into the tissues. They're more powerful than macrophages, but they don't last very long. Their job is to get in there and kill the microbes. They only last a couple of days compared to many days or weeks for our macrophage. And once they have used up their granules, they die. So they get in and they kill and die. Our macrophage can keep on eating. Our neutrophil kind of like gets in there and is kind of so powerful it only has kind of one shot. Our neutrophil is a granulocyte. Its granules contain all kinds of destructive chemicals. And it'll send those granules into the phagolysosome to destroy bacteria. But if you can't get the job done destroying bacteria internally, it will release those granules into the environment. So we have our neutrophil here. We have our invading microbes. The neutrophil has all of these granules full of chemicals. It'll send these granules to its membrane. It'll bind them to the membrane, and all of the chemicals that were in those granules will be released against the bacteria in an attempt to kill them. This is good because it kills the bacteria, but it's bad for us because this is all happening in our own tissues. So there are your own body cells here, and the chemicals that destroy these bacteria are also going to damage your own cells. So down at the bottom here we have degranulation is analogous to a grenade. Instead of eating the bacteria one by one and killing them, you release your toxic kind of blast in hopes to kill the bacteria. Our neutrophils have another kind of weapon up their sleeve. They can barf out their DNA. Again, if they can't, or if they don't think they can get the job done, they can trap and ensnare any bacteria in the environment and then release chemicals to destroy them. DNA is very, very long and very, very sticky. So our neutrophil comes to a site. It decides that the best course of action is to snare the bacteria and release chemicals. So it barfs out its DNA. All of those DNA strands snag up the bacteria, and then the release of chemicals hopes to destroy the bacteria, or indeed prevents the bacteria from escaping at least, so that other phagocytes can come in and finish the job. The barfing out of its DNA is called a net, or a neutrophil extracellular trap. So number 29 is our study guide. First of all, we have our different phases of our macrophages, and then we have the difference between a neutrophil and a macrophage. So number 1, our neutrophils are more powerful. Number 2, our macrophages live longer. Number 3, our neutrophils have granules. Number 4, our macrophages can regenerate their lysosomes. Our neutrophils are kind of one and done. They release their toxic chemicals and then they die. First responders, number 5, that's our neutrophils. Significant components of granulomas, that's our macrophages, walling off the bacteria, trying to just contain it. Releasing DNA and catching microbes, number 7, that is the job of neutrophils. Neutrophil extracellular traps, when the neutrophil barfs out its DNA. Okay, that's the end of this section.